What's up, you guys? We are in geometry. This is page 477. Consider angle C. Use construction tools to draw a segment that bisects angle C. I realize if you watch page 476, I've bisected angle B. That one's already been done, so we're going to do some more adjustment. Look ahead. That's the moral of the story from yesterday and today, or from the last video, this one. Instead of using the tracing paper, which I realized was close but not quite accurate enough, I'm going to try a different way to be more accurate. I'm going to bisect angle C literally by measuring the angle and dividing the measure of the angle by 2. So to use the protractor to measure angle C, I have to extend this angle out and then use the protractor to measure it. So here's what I do with this one. I'm going to take the center hole. Oh, pause. If you already know how to do this, skip forward like a minute and a half. If you don't know how to use a protractor to measure, stick around. Now, the hole in the protractor, that's the center. I'm going to put it on the vertex, C. And I just naturally start to line it up. But like if you set it up, you have to measure that angle number and that angle number and subtract. That's one way to use a protractor. I like putting the 0 on that edge. And then I extended the line because this little line of the triangle didn't go out far enough to be read by the degrees on the edge of the triangle. But now that I've done that, I can see that I have a 31-degree angle. 31? Yeah, no fudging. It's 31. All right, so 31 degrees. Half of 31 is 15.5. So since the triangle is the way it is and the protractor is there, I'm going to put a mark at what I think is as close to 15.5 as I can get. So not 160, 170, but the 10, 0, 10, 20. So 10 right here, 20 right here, 15 is right in the middle. I want to be a little bit off from that. And now, using my protractor and being as careful as I can with my straight edge and the amount of pencil lead that there is, I'm going to draw a line lined up. I want a segment. That's the key thing. I want a segment that will represent the angle bisector, and the segment is going to go just to right there. You have to get that right. We're going to label it point E. Do not mess that up. The only way you can mess that up is that you were not accurate in the way you created your angle, and that's some skill that you have to follow. Now, determine the ratio of the length CB to CA. CB to CA. Oh, this is different than this poster. There's a couple of different ways we can create those ratios. So that's what I'm showing you here. Millimeters to the rescue. So setting the millimeter mark there on 0 and then lining it up as carefully as I can. CB is approximately 24 millimeters. 24 mm. And then CA, let's do the exact same thing. So CA, lining the protractor up so that A is on 0. That looks like 35. I could say 35 millimeters, right? So 10, 20, 30, and then 35 there. Okay, so 35 millimeters. Hey Siri, what's 24 divided by 35?
24 divided by 35 is approximately 0.6857.
Okay, we got a couple of decimals there. Determine the ratio of the length BE to the length AE. So we're talking B to E, A to E, millimeters to the rescue. And write it out. BE to AE. Oh, I had a comment with another teacher just the other day that if we write a ratio, shouldn't we be using the 2 dots like a colon? Let's all just stick with fractions. Fractions is how we're going to write our proportions. You're going to see them written in proportions all over the place. Write them in fraction format. Write your ratio as a fraction. That's the bell for this class right now. I'm time dating the thing. Lunch is beginning for some of you at this exact moment in time. Okay. I can't measure the whole length and divide. That won't work. But I can measure from 0, 5, 6, 7, maybe about 8 millimeters. BE is 8 millimeters. Millimeters are slightly more, since they're smaller than 1/16 of an inch, they're a little more accurate than using the inch, 1/16 of an inch measurements. You should know your fractions though, especially on like a standard like imperial ruler. Okay, so this looks like approximately 11 Yeah, I'm going to say that's 11 millimeters. 11 millimeters. Hey, Siri, what's 8 divided by 11?
8 divided by 11 is approximately 0.7272.
Whoa, those are really, really close. I mean, in terms of dollars and cents, this is like 68 cents and this is like 72 cents. We're only off by 4 pennies. What do you notice about the ratios you determine in parts B and C? They are relatively close to each other. They are relatively close to the same number. Okay, everything that I did in this one, the idea here is that when you have an angle bisector, it's going to create these ratios that will be equivalent. So go watch the poster notes video where I at least talk about what's going on this poster with the fractions. But what I think I just realized, and I need to add it now, so you're seeing it here for the first time, I could have even made x to 8 as a possibility, but I'd have to make 25 to 10 be the other possibility. And that's a little bit different than the color scheme that I have from this one. So, just add to it your understanding how you make your proportion is important. At this point, I'm going to say, again, class has begun for some others of you. Pay no attention to those numbers I'm talking over, just to remind you, don't worry about it. I'm going to say I'm doing no words for the rest of this video. Yay! But what I'm trying to do is say, repeat. You've seen in page 476 what you're supposed to do from angle, I guess angle B. So in this one I will acknowledge, I'm going from angle A. I switched them around, whatever. But I want you to do angle A, and you can do it exactly like I did here. And I will go ahead and show you exactly everything I'm going to do for angle A. If you've got it, you're done with the video. If you don't, stick around, but I'm also not going to do a lot of talking. I'm just going to work. No, watch me work. Okay, so this is an angle bisector. Need to draw. Okay. I might talk a little bit. I'm sorry. I'm not trying to talk, though. Just a reminder, I'm not trying to do too much talking. You already saw how to do it. Now just go work it out. Maybe you're skipping ahead every so often just to see if we line up. That's right, I skipped it, so I got to make sure that I'm keeping angle. I'm flipping it. I should just look at this one. BC, BD. Okay. Here we go. 35. Hey Siri, what's 19 divided by 35?
19 divided by 35 is approximately 0.5428.
Let's say the 2/8 rounds to a 3. Okay, ratio of AF, but it's not AF, it's BF. Okay. Hey Siri, what's 8 divided by 17?
8 divided by 0.4705.
Hey Siri, what's 8 divided by 18?
8 divided by 18 is approximately 0.4444.
I'm gonna say it was a 16 millimeter, just round a little bit. Okay, what do you notice between those two? The ratios are approximately equal. Make a conjecture about the angle bisectors of a triangle and its side lengths. The ratios are approximately equal. I'm leaving it that way. Okay, this has been it for page 477. Thank you if you made it to the end of the video, or if you just have been working and it's just playing in the background. Anyway, point being, I'm done. 478 is next. See you in the next episode.